General Kenobi!
Hello there, my name is Jayton Acey. I am currently a freshman at ASU, and I am majoring in physics with an emphasis in secondary education. I'd like to show you guys something I think is pretty cool. If we take a look back at that introduction video, it may not seem like much, but physics is actually behind the whole how that video actually works, how that clip works. And basic sum of it is, well, gravity causes things to fall. Just as simple as that. But if we take it a step further, through physics we can actually figure out how far he fell and how fast he was falling.
Okay, here's our basic setup. Okay, we got General Kenobi up top, we got General Grievous down the side, or down at the bottom. We've got our height represented by y. Okay, now what do we know? We know gravity, the acceleration due to gravity is 9.8 meters per second. Our initial velocity is 0 meters per second. And for our time, we need to refer back to the video. So, we can figure out, okay, it's about 2 seconds. It starts from 5 and it goes to 7. Okay, now let's get back to the now let's go to the equation. Y equals 1/2 acceleration times time squared plus velocity initial times time. Okay, so from there, I forgot to mention this before, but our acceleration is gravity. Gravity is what's causing it to fall, and gravity is actually an acceleration in its problem. So we can go y equals, and replace acceleration with our g value, then times time squared. And then from there, since our initial velocity is 0, that means that our other term can cancel out to 0 as well. So y just means equals 1/2 gravity times time squared. Okay, so we'll plug the numbers in. I forgot to do this before, but it's actually negative 9.8 meters per second squared, because it's down, and then times our 2 seconds squared. 2 squared happens to be 4, but then multiply that by 1/2 and you get 2 times negative 9.8. So then our final distance traveled is going to be 2 times negative 9.8, which is negative 19.6 meters. So we'll go ahead and replace that over on the side instead of y. Okay, so next up, what we were going to do is we're going to look for the final velocity. How hard or how fast was he traveling as he hit the ground? Our equation for this is our final velocity equals our initial velocity plus acceleration times time. Again, our velocity initial is 0, and our acceleration due to gravity is negative 9.8 meters per second squared. So what we can do is, that just transforms that into gravity times time. So, again, with our initial velocity equaling 0, our term cancels out to 0, so our final velocity is just equal to gravity times time. Okay, so now we'll plug in the numbers. So that is velocity final equals negative 9.8 meters per second squared times 2. And that turns out to be negative 19.6 meters per second squared. So now, to take it a step further, we're going to look at the force. How hard was he hitting the ground? From Newton's, I believe, second law, we learned that force equals mass times acceleration. And in this case, our acceleration is not negative 9.8 meters per second squared, the value of gravity, because gravity is not what causes the force with that. I looked up the mass on Wikipedia, the Star Wars wiki page, and figured out that his mass was roughly 81 kilograms. So we're going to use that value. But now we need to figure out our acceleration value. So acceleration is equal to velocity final minus velocity initial, or the change in velocity over time. So our acceleration is equal to negative 19.6 meters per second squared minus 0 meters per second squared. And because we can't divide by 0, but I want to make it as close to instantaneous as possible, and so we have a nice number, I'm just going to put 1 second. This is obviously a rough estimate, but then that puts us at our acceleration being negative 19.6 meters per second squared. So now let's go back. Okay, so our force equals 81 kilograms times negative 19.6 meters per second squared. We multiply that out, and we will get our answer. Now, quick disclaimer, this numbers are just approximations. They are not exact. I am lowballing them a little bit, because as we see in the video, he did jump a little bit. So it's not exactly initial velocity equal to 0, but it works. So our force is negative 1587.6, and those are in newtons. That's pretty hard.
Thank you guys for watching. I hope you enjoyed it. I know I personally enjoyed physics really much, a whole lot, and if you did enjoy it, consider taking physics in your high school. A lot of high schools out there are offering physics, and it's a lot of fun. There's a lot of hands-on activities, and it's personally one of my favorite classes that I took in high school. But there's a place for everyone. You're always welcome to do so.
Hello there.
General Kenobi!